In this video, we're going to talk about the difference between value types and reference types, and talk a little bit about the memory storage system involved in all of that. So to start off, we're going to talk about value types. So when you think of value types, you should think of primitive types, those numbers, booleans, and strings that we've talked about before. Let's go ahead and declare some of those types and talk a little bit about what happens in memory when we do that. So say we want to create a number, and we can call it x. So we'll say let x be of type number. Right when we type that line of code, your computer puts a box in memory that is big enough to store a number. So then once you say x equals 5, your computer will say, okay, I'm going to take 5 and put it in that box in memory that we labeled x. Great. So now say we create a number called y. So let y be of type number, and we'll set that equal to 6. Once again, we've created a box in memory called labeled y, and it has the number 6 stored in it. So now, what happens if we say x equals y? Well, basically, what your computer does is it goes and it finds y in memory and grabs what's inside that box, and then puts it in x's box. So now we have x in memory associated with the number 6, and y in memory associated with the number 6. And you can assign number values to other number values, just like we do with our counter and our while loop. So you could say just plainly y equals 8. And if you see, if we print x right now, the number 6 is printed, not the number 8, even though we changed y after that. And that's just because we copied the value. We didn't reference it. Great, so we just talked about how numbers are value types because they're a primitive type. So in memory, the value is stored. But also you can do the same thing for booleans and strings. So if we make a string, let's say let name be of string, and let's set the value equal to Kate. If we then say let other name be a string and set the value equal to Hank, if we say name equals other name, in memory, Hank now is name's name. So we just assign name equal to other name, so the box labeled name in memory is now filled with Hank. But let's change what the other name box in memory is filled with. So we'll say other name equals Carly. So now other name in memory stores Carly. But if we print name and we print other name, name still prints out Hank despite the fact that other name now prints out Carly and stores Carly. So even though we said name equals other name, it does not continue to change as other name does, because all we did when we said that was copy the value of other name once. So the final primitive or value type are booleans. So just like before, you can store true and false values in memory. So say we say let a bool be of type boolean and it equals true. Just like before, a bool is a box in memory that stores the value true. So let's go look through all the memory of our TypeScript page right here. We have x is 6, y is 8, we have name is Hank, we have other name is Carly, and then we have a bool is true. So all of these values are stored directly in memory.
Alright, so we just talked about what happens when we deal with variables that are these primitive data types, number, string, or boolean. Whenever we assign a variable something that's a primitive data type, that value gets copied into the box in memory that holds that variable. But this works differently if we talk about reference types. So everything we just talked about is a value type. Now we're going to talk about reference types. One example of a reference type is an array. Anything that's an array is a reference type. And all that means is that instead of the box in memory actually storing the value that the variable holds, it stores a reference to the place in memory that actually stores that value. So you can think of it like we're building up this stack of memory, right? So when we're dealing with primitive types, we just create a box, fill it with the right type, create another box, fill it with the right type. But when we create a reference type, we create a box and we put an address in it that says, go here to get the data that you're looking for. So let's look at an example. Let's say we have an array of scores. So we're going to say let scores be of type number array, and we're going to initialize it to this random array of numbers here. So now we have a number array in memory, and after that line we're going to declare another variable that's of type number array. So let's say let other scores be also a variable that's of type number array, and we're going to assign that other scores variable the scores array that we originally created. So we'll say other scores equals scores. So if this were a value type, like we've talked about so far, we would say that the computer goes in and copies over the thing that's in the box that we're on the right side of the equal sign to the thing that's in the box on the left side of the equal sign. But these are reference types. So the box in memory only holds an address, a reference to where that thing is. So what gets copied over is the reference, the address of the location in memory of that data, so it ends up pointing to the same exact data in memory. So when we say let scores be a variable of type number array, we create a box that's big enough to hold an address, a reference. But when we initialize that variable, so when we say equals this specific array of numbers, we go to a different location in memory called the heap. You can think of it as like a heap of data that we're looking at, a heap of big kinds of data like arrays. And put that data there, figure out what the reference, what the address of that data is, and store that reference in our stack of memory over here. So then, on the next line, when we say let other scores be a variable that's of type number array, over here in memory we create another box that's big enough to hold a reference to a number array. And then when we say, the important part is when we say other numbers equals, or other scores equals scores, we do the same thing we did with value types, in that we copy over what's in that box, but what's in that box here is a reference to this specific chunk of data. So the same reference gets copied over. You can think of it as like an arrow. We get like an arrow pointing to the same chunk of data. So the way we can prove this to you is if we modify some value in this chunk of data, it should get modified for both of these variables that point to that data. So let's say other scores, let's make the thing at index 0 of underscores be 100. So other scores at index 0 gets the value 100. Now what we've done here is what the computer does, it says, okay, go to other scores, and then go to the data that that address points to and change the data there. So now if we print out scores at index 0, we'll get 100 printed out to the screen. Because scores at index 0, when we say get the value at index 0 of scores, it follows the arrow, and that arrow points to the same chunk of data that we edited. Alright, so that's what happens when we deal with arrays. The same thing happens when we deal with classes. Classes are also this composite data type. We're storing a bunch of different kinds of data, different variables within our class. So classes are also an example of a reference type. So let's create a class. Let's say we have class dog, and inside that dog class, every dog is going to have a name. That name is going to be of type string. The dog will also have a sound that's going to also be of type string. That's going to be the string wolf. We'll initialize that there. And we'll have a number of legs property. That's going to be a number, and we'll initialize that to be 4. Great. So we've got our dog class. Let's create an instance of it. So we're going to say let spot be a variable that's of type dog. Cool. And all that does, because this is a reference type, is it goes in our memory and creates a box that's big enough to hold an address, big enough to hold a reference to where that data is. Then when we say spot gets assigned new dog, that new keyword means we're going to actually create all of the data in memory that we need. So we're going to go over to our big heap of reference type data over here, and create all the data we need. A name that's big enough to hold a string, number of legs, and a sound. And then fill in the box over here with a reference to that data. Cool, so let's give Spot its name. Actually, we'll say spot.name equals the string Spot. Cool. So let's say Spot gets adopted by a new family, and that new family wants to rename Spot to Fido. So let's make a new variable to hold this new dog that the family gets. So we'll say let Fido be a variable of type dog, and Fido gets initialized to Spot. So we're passing in our Spot instance that we had before and initializing Fido with that. So what happens in memory, remember, is we just copy over the reference to that same data. So we have two variables now that point to the same data. So if our new family then changes Fido's name, so we'll say Fido.name equals Fido, then if miraculously the beginning family got the dog back and checked what its name was, it would have changed because those two variables point to the same data. So if we say print spot.name, now Spot's name is also going to be Fido. Alright, and that's the basics of value types versus reference or composite types. Just remember that when you're dealing with simple primitive types, number, string, or Boolean, values get copied over in memory. And when you're dealing with more complex types like arrays or classes, you copy over an address that points to the data in memory.